Hey guys, how are you doing? So let's solve another interesting question in probability, which says that we need to choose n points at random, uniformly and independently on the circumference of circle. Find the probability Pn that all the points are lie on a semicircle. Like, what is the probability that if we select points at random, then all those points will lie in the same semicircle? That is what this question means. So that is a bit of intuition based diagram which I drew. Now let's think about what happens mathematically. Okay, sorry for my very good circle which I drew. Let's select the first point over here. Okay, in how many ways can we select the first point? NC1 ways, right? In NC1 ways we select the first point. Now this first point is the game changer, because once we set the first point, we now know what is the diametrically opposite point, and now we know that this should be the range or this should be the range, right? Either all the values should be in this semicircle, or either all the values should be in this semicircle. Okay, so let all the values be in this semicircle will have a probability P1. Let's say all the points will be in this semicircle be P2, right? So it is quite obvious with symmetry that P1 will be equal to P2, right? That is quite obvious. Okay, so now basically what is the total probability? If we fix this, if wherever our second point is, let's say our second point, our second point in this side, then it's obvious that all the points will have to be in this side. They cannot be in this side, right? Cannot be in this side. So that is that all the points should be, if our point is in this side, as in let's say here is our point, then we have to be pretty sure that all the points should be in this semicircle only. That is pretty much clear, right? So okay, so that's it. So what is the total number of ways in which we can select the first value? The first value is the game changer, and the second value is we select any point over the whole circle. So that's cool, we don't worry about that. And then once we fix it, there is a half probability that each of them will be either side, right? So we are fixing one side, then we have to go for all n-2 values, we have to go one side, right? So this is the total probability, but total probability is P1 plus P2, right? Is NC1 into half by of n-2. So pretty much P1, and as P1 equal to P2, we can say 2P1 is NC1 into half of n-2. So let's solve this. P1 will be equal to NC1 into 1 by 2 power n-1, which is n by 2 to the power n-1. Let's do some sanity checks here. Sanity check. What is the probability of selecting one point, which is let's say if we call this P of n, if we call this P of n equal to n by 2n-1. What if there is only one point? What is the probability that it will be on the same semicircle? Obviously it will be 1. If there are 2 points, wherever the 2 points be, we can make the semicircle like that. So obviously it is also equal to 1 only. What about 3? 3 is 3 by 4, and so on. So basically sanity check can be done with these two. Now the question asks for a more general solution, in which we fix a phi for the sector, and we are not thinking about the semicircle, but we are thinking about the sector phi. So how do we solve that question? Again, the first value is the game changer, because once we set the first value, we know we have these two sectors in our hand, right? We cannot go beyond these. Now the catch of the second value is the second value cannot be anywhere in this circle anymore, because that was semicircle, hence it could have been anywhere, but this time the second point would have to be in this sector, that is 2 phi, the sector which has a which makes an angle 2 phi at the center, right? So again, let's say the probability that all the points lie in this sector and the probability that all the points lie in this sector is P1 and P2. So again, P1 will be equal to P2 obviously, because it's quite symmetric and you can see the symmetry. So again, 2 of P1 we can say will be, now we need to, okay, let's not jump too many steps. So let's see the total probability of ending up in either of the, of all points ending up in either of the arc. So again, we select the first point, which will be the game changer, and after that what happens is we select the second point, like 2 phi by 2 pi, like we select any point in this 2 phi sector out of the 2 pi angle which the total is, into 5 by 2 pi to the power n minus 2. This is clear, right? NC1 into 5 by 2 pi. So basically total probability, which is 2p1, is n into 5 by pi into 5 by 2 pi to the power n minus 2, right? So what is p1? 5 by 2 pi to the power n minus 1. So this is the answer. Basically, how does this 5 by 2 pi came? When we select the second value, we now know that we fix, like we cannot go further, like this is the arc which we have to select, and there is no other option, and hence 5 by 2 pi is the probability of that arc. And if it was not selected, the second point could have been anywhere in this total arc, right? 2 5 by 2 pi, and hence it was like that. Now the probability that all of them are in one arc is n into 5 by 2 pi. Now if you put phi equal to pi, you will see our answer of our previous answer coming out to be true. So yeah, that's that, and you can do some sanity checks if you want to, but yeah, I'll leave you to that, leave you to do some observations and check out if this equation is making sense or not, this answer is making sense or not. So yeah, that's it from my side for this question. I hope you liked the video. If you liked it, please share it with your friends who are interested in maths as well. Okay then, bye.